ever get stuck in traffic and just wish someone or something could figure out like the absolute fastest route?
Or maybe you're amazed by how those online orders you place somehow magically appear right at your doorstep.
Right. Like, how does that even work?
It really does seem like magic sometimes, but it's often thanks to some pretty clever optimization algorithms working behind the scenes.
And those algorithms are tackling some seriously complex problems. And that's actually what we're diving into today.
Yeah, we're going to be looking at.
We've got this Google research article
Mm-hmm.
all about a tool that can solve these massive optimization puzzles, ones that would probably make even like the brainiest supercomputer just kind of go, whoa.
Yeah, these are the types of problems that would make even a supercomputer sweat a little bit. We're talking about optimizing the flow of information across Google's entire data center network.
Okay, so we're not messing around here. We're in the big leagues. But before we get too deep into the weeds,
Sure.
can we just touch on the basics?
Yeah.
We hear this phrase linear programming all the time. Is that what we're talking about here?
Exactly, yeah. Linear programming, or LP, as it's often called, is kind of like the backbone behind a lot of these optimization methods.
Okay.
It helps us make the absolute best decisions when we're facing a ton of different choices and limits.
So less about actually like programming, more about just solving these big problems.
Exactly. It's all about problem solving. Maybe a good way to think about it is to imagine you're managing a huge fleet of container ships. You need to map out the most efficient routes for them all. You've got to factor in fuel costs, delivery deadlines, even something as specific as how those containers are loaded onto the ships. That's a really classic example of an LP problem.
Wow. That sounds super complicated, though. How does LP even begin to solve something like that?
So it basically provides this framework, a way to mathematically define all of those factors, all those constraints, And once we have that, we can use these really powerful solvers to crunch the numbers. And they help us find that one solution, the one that's going to either keep costs as low as possible or maybe maximize efficiency, depending on what we're going for.
So it's like having a superpowered spreadsheet that goes through like millions of possibilities in a split second.
Exactly. Like you said, it's super powered. And the same kind of approach, it's not just for container ships either.
Right.
We see it everywhere. It's used in finance, in healthcare.
Right.
Even in something as simple as planning the traffic lights in a city.
Oh, wow.
But
it's amazing.
There's always a but, right?
Right.
Traditional LP methods, they kind of hit a wall when the problems get really, truly enormous.
But how do you even start to solve a problem that big? I mean, that's got to be where this Google innovation comes in, right?
You're exactly right. Google realized they needed something more.
Okay.
So they developed a new solver that can handle those supersized LP problems. They call it PDLP.
PDLP, does that stand for something? It actually sounds a lot friendlier than I expected for something that crunches numbers on such a huge scale.
I know. Don't let the name fool you. PDLP is a total powerhouse.
Okay.
It's a completely different approach from those traditional methods. And to really grasp how clever it is, we need to take a closer look at how it handles those massive calculations. To do that, we need to dive a bit deeper into the world of algorithms.
Okay, you've definitely piqued my curiosity. Let's do it. Okay, so algorithms.
Yeah.
Are we about to go full on like Matrix mode here?
We could, or maybe a better way to think about it is, imagine you're trying to build something really massive out of Legos, right?
Okay.
But you've only got the instructions for a much smaller version. You could try to just scale it up piece by piece, but that would be crazy slow. And you would need a ton of Legos.
A lot of brain power too, I bet. So is that kind of what those traditional LP solvers are stuck doing? Like they're just trying to brute force their way through these huge problems?
Pretty much. They use this thing called matrix factorization. It's like taking that Lego structure and basically disassembling the whole thing just to try and figure out how it all fits together. It gets the job done, but it's not exactly what I'd call elegant. And when you're talking about problems on Google's level, well, it's just not the most efficient way to go about it.
Okay, I'm seeing the problem here. So how does PDLP do things differently? Does it have a better way of handling all those Lego bricks?
You got it. It uses this technique called restarted primal dual hybrid gradient.
Okay.
Ellipses. I know, that sounds super intimidating.
Just a little.
But bear with me, it actually makes a lot of sense when you break it down. Imagine a self-driving car trying to navigate its way through a busy city.
Okay.
If it tried to plan out like the entire route ahead of time, every single turn, every stoplight, well, one little traffic jam and the whole plan goes out the window, right?
Yeah, totally.
So instead of doing that, it constantly analyzes what's happening around it in real time and adjusts its course to find the most efficient path.
Oh, so it's like PDLP is constantly recalibrating, making sure it's always on the fastest track to find the solution.
Precisely. It's all about those strategic restarts. They're what let PDLP cut through all the noise and find the optimal solution so much faster than traditional methods.
I bet. And does the article talk about how well that actually works in practice?
Yeah, actually, there's this really cool visualization in the article that shows PDLP just zeroing in on the best solution, like a guided missile. It's incredible, especially when you see it compared to those other methods that are still kind of wandering around trying to find their way.
Yes, I can picture that. Okay, so PDLP can theoretically handle these massive, massive problems, but where's the proof? Like, where is it actually making a difference in the real world?
Well, let's go back to that first example we were talking about. Google's data centers.
Right, with the container ships and all that.
Exactly. So those data centers, we're talking about these giant networks that are processing like an insane amount of data.
Every second of every day.
Nonstop. PDLP helps make sure all of that information is flowing as smoothly and efficiently as possible.
Oh, wow. So the next time my streaming doesn't buffer, even if I've got it cranked up to like the highest quality, I can thank PDLP for keeping things running.
You got it. And it's not just about faster internet for us either.
Okay.
This level of optimization means that Google can use way less energy in their data centers, which is a huge win for the environment.
It's like a win-win situation for everyone.
Yeah.
Now, you mentioned container ships earlier, too. Is PDLP actually out there, like, helping those massive ships navigate the oceans more efficiently?
Absolutely. Remember when we were talking about figuring out the absolute best routes?
Yeah.
Taking into account things like fuel costs, delivery times. That's where PDLP really shines. It's helping make those global shipping routes much more efficient, more cost-effective, which actually has this ripple effect on the entire global economy. It's pretty amazing.
It really is. This might be a tough question to answer, but
Yeah.
is there a limit? What's the biggest, most complicated problem you've heard of PDLP solving?
You ready for this? They used it to solve a version of what's called the traveling salesperson problem.
Wait, I've heard of that. Isn't that the one where you're trying to find the shortest route to visit, like, a bunch of different cities?
Exactly. It sounds simple enough on the surface,
Yeah.
right? But as you start adding more cities, the number of possible routes just explodes.
Right.
In this particular case, we're talking about a problem with something like 12 billion non-zero entries in the constraint matrix.
12 billion. Okay. Wow. I don't even know if I can even really picture a number that big. That's insane. So clearly we're talking about solving problems that, like, a few years ago would have just been completely impossible.
Exactly.
But, not everyone listening is managing container ships or data centers or anything like that.
That's very true, but that's kind of the beauty of this whole story.
Okay.
PDLP's impact goes way beyond Google and these super specific applications.
So before the break, you were saying that PDLP is making an impact, even outside of Google.
It is. It really is. And it's not just about solving those massive optimization problems. It's about something much bigger.
Okay. I'm intrigued. Tell me more.
So Google, they didn't keep PDLP a secret. They actually did something really cool.
What's that?
They open sourced it.
Wait, hold on. They just decided to give it away. Why would they do that?
Well, that's the beauty of open source. It's all about collaboration. By sharing it with the world, they're letting anyone, researchers, developers, whoever, they can take it, build on it, maybe even come up with solutions to problems we haven't even thought of yet.
Wow, it's like they're planting a seed and they're just letting anyone, anywhere, see what grows from it.
That's a great way to put it. And the really cool thing is, it's not just researchers and labs who are using it.
No, who else?
The article mentions that even some commercial companies, the ones that build optimization software, they're starting to incorporate PDLP into their products.
You're kidding. So you're saying that soon all sorts of businesses could be benefiting from the same tech that powers Google's data centers.
Exactly. Think about it. Optimizing delivery routes for shipping companies, making healthcare logistics way smoother. PDLP could even make renewable energy grids more efficient, which could be a game changer in the fight against climate change.
This is really making me think about algorithms in a whole new light. It's easy to think that these super advanced technologies are only relevant to, a select few. But what you're saying is that PDLP shows that these breakthroughs can have a ripple effect that goes way beyond those initial applications.
100%. It really highlights what we can achieve when we work together, when we're not afraid to share knowledge. That's how we make real progress.
It's inspiring, honestly. So to wrap things up here, what's the one thing you really want our listeners to take away from our deep dive into PDLP?
PDLP is more than just a tool. It's a whole new way of thinking about how we solve problems, especially in this day and age. The challenges we're facing, things like climate change, resource management, they're only getting more and more complex, right?
Right.
But PDLP, it gives us hope. It shows us that we can use our ingenuity, along with all this incredible computing power we have now, to actually tackle these huge problems head on.
It's like we're entering a new era of optimization. The impossible is starting to seem possible.
And that actually leads perfectly into my final thought for everyone listening. We've spent all this time talking about how PDLP is changing everything, how powerful it is. But the real question is, what will you do with this knowledge? What can you do differently now that you know this exists? The next time you run into a problem, no matter how big or small, remember PDLP. Think outside the box. Don't be afraid to collaborate. And never, ever underestimate the power of a well-optimized algorithm.
And on that note, we're going to wrap up our deep dive into the incredible world of PDLP. We hope you've enjoyed this journey into the heart of optimization. We'll see you next time, but until then, keep exploring, keep asking questions, and as always, keep on diving deep.